Alright, this is a throwback question. So it involves a 5 kilogram object that's attached to a string. It's moving in a circle, so we're going to talk about circular motion again. So with that in mind, you have to think about, well, what equations do we remember from circular motion? So the one that's on your equation sheet is the one for centripetal acceleration. So AC is equal to velocity squared divided by the radius. And we don't know what the acceleration is, we're not looking for the acceleration, so we're going to have to figure out something to sub in there. And that's not too hard because we remember that, so acceleration is equal to force divided by mass. In this case, we have a centripetal acceleration, we have a centripetal force. And it does tell us that the string is providing that centripetal force, and so the force on the string, the tension, will be our centripetal force. So let's put these two equations together, and when we merge them, what that's going to do is that's going to give us Fc divided by mass is equal to velocity squared divided by the radius. Alright, so that's our equation for circular. So if we check off the stuff that we know Fc, that's here. We are looking for the radius, so the radius is our unknown, what we're trying to find. We're given the mass up at the top, and so out of that equation, the only variable we don't know is the velocity. So we need another equation, because we have two unknowns. We don't know velocity, we don't know radius. Now, let's look and see what other information they give us. They do also tell us the kinetic energy of the object. So we have another equation that we can use, and that's the one for kinetic energy. So let's do it this way. Kinetic energy, K, that's our given over here, that's 10 joules, this is K, and that's equal to 1/2 the mass multiplied by the velocity squared. So I know the kinetic energy, I know the mass still. So that means that v squared is the only variable that I don't know in that equation. So you have two options. We can do this in two steps. We can do the blue equation to find the velocity squared, and then we can do the pink equation to find the radius. Or we can merge those two equations together. And if we're going to merge them together, which is what I'm leaning towards doing, then I want to isolate the variable that we're not going to need, that we're not going to use, that we don't know. So I'm going to move around my equation, and I'm going to solve the kinetic energy equation. I'm going to solve it for v squared. So if I move the fraction over, that gives me 2 times k divided by m. And we can do the same thing over here for the pink equation. And that's not too hard to do. We just have to multiply by r on both sides, and multiply by r on the right side. Those will reduce out, so I can get rid of them. And then we'll have both equations solved for v squared. And now that they're both equal to v squared, we can set them equal to each other. Alright, so let's see if we can follow this. So I have the centripetal force, which is the tension, times the radius divided by mass. That's going to be equal to my other equation over here, which is 2 times the kinetic energy divided by the mass. Now you'll notice that we're dividing both sides by mass, which means we can reduce both of those out. So technically we don't even need the mass. And you can see the advantage of merging equations together. This is going to be a pretty simple and straightforward relationship. So now all we have to do is just solve for R, and that involves dividing by the centripetal force, or dividing by the tension. So we divide by Fc on the left side, we divide by Fc on the right side. These will reduce out, they go away. And so now I have a simplified equation. So we just have to do 2 times the kinetic energy and divide by the tension. So let's go ahead and plug our numbers in. R will be equal to 2 times 10, that would just be 20, and then we're going to divide by 276. So 20 divided by 276 will give us an answer of 0.07246. Remember, we want to do 4 numbers. So don't round it off too soon. And this will be our radius. That's our final answer.